Hello, welcome back to another episode. Today we're going to be talking about the property decorator. This is kind of an extension to a previous video where I talked about decorators in general, but we're going to drill into the property decorator specifically and show you some places where you might use this decorator in your code. Let's jump into it. All right, so I'm actually going to use some sample code. Well, I'm going to write out some sample code that was showed to me from one of my viewers, Michaela, who's working on a little game. And part of the game involves, it's kind of like a cool RPG thing, and you move around a location, and Michaela is just learning, or just starting out learning Python, and had implemented a location class, and I'm going to show how we can change her implementation of the location class to utilize property to, function a little bit better. So first I'm just going to sketch out basically what that class looked like before I suggested that, property might be a good solution. So let's jump into that. So it looks something like this. Oops. Just a basic location that had an X and a Y, and she also had a pairwise version of that. And we'll actually replace this later with a property. Those of you who know the trick have already jumped ahead of that, but we'll just implement it as if we didn't know about property before that. And so it had a couple of methods on it. So like, let's say it had move left, which did self.x minus equals 1, and maybe a move right, did self.x plus equals 1, and move up. Up would be subtracting 1, yes. Assuming we have a coordinate plane that goes, increasing x and decreasing y. It's kind of the, as far as I know, it's kind of the standard way to do that in games, is to have 0, 0 be up, top left, and then go positive, wait. No, did that backwards. Yeah, no, that's right. 0, 0 be top left, and then big X and big Y be bottom right. So this is kind of the structure of the class that she wrote, and you'll notice there's a bug here if we run this. I'm actually going to use Python 3.8-I and then pass a file name. This is something that I didn't know when I started up in Python, and I wish I knew earlier. But this will give you, it'll run this file, and then it'll give you an interactive prompt after that. You can see we have an interactive prompt. We can access the location class. We can make one of them equals location. And now if we do location.move left, you can see the location.x and location.y moves to that. Actually, let's to make this demo a little bit better, we're going to implement a Repre. This is probably do another video on Repre at some point, but the idea behind Repre is it's supposed to be a representation of your object as opposed to the stringified version of your object, and that's what Python will show in your terminal when you're looking at that. Or if you called Repre directly on it, you'll get the string of that. And it's kind of a good idea to, when you're making a Repre, represent the way you would construct one of these objects. Of course, in this case, we don't have parameters in our init, but you could imagine, like, well, we can just do that real quick. X equals 0, y equals 0, and then we could do x, y. So we just added defaults here. But anyway, what I would do for Repre, typing and talking. How do I do this? We're gonna grab the name of the class. It is a constant string, but if we were to refactor this is a little bit more future-proof. And then we can give the variables here. So we do self.x and y equals self.y, and this is all wrapped up in a format string, an f string, which I really like f strings. They're pretty cool. But you'll see we do this again. And we build a location, we now get this like prettier thing. And kind of the rule of thumb with Repres is if you were to copy and paste it, you should go back the same object. It's not always true, and sometimes there are objects that are intentionally unrepresentable or like not individually constructible, but that's for another video. Anyway, back to our example. We make a location and we do loc.move left. You'll notice that X and Y get updated, but this loc object is still pointing at the original values, which is a bit of a problem. And so what Michaela did, and this works and like it's completely valid, was to make an update loc function, which set self.loc equal to self.x and self.y, and then called that function in all of these places. Update loc. And this does work, but it's a little bit repetitive. You'll see now if we make a location, do move left, X and Y get updated, and now the, I call it loc? Loc.loc? Now loc.loc also gets updated. So this works. This is completely valid in like one way that you could implement that. But one thing you'll notice is that we have a little bit of redundant data here. We're storing the X in two different ways, we're storing the Y in two different ways. And property comes to the rescue here. So the property is, or like what you would call it if you were working in like some generic programming language, is property implements getters, and later we'll get to setters and deleters, but in this case we're basically just calling it a getter. And so what you can do is, let's delete this. Actually, we can probably just undo some of this to reduce the amount of code we have to delete. Okay, so we're back to what we had before, and we've deleted loc, but we're gonna actually make a property, and we can just return self.x and self.y. And so now if we run this, make our location, you can see if we look at loc for that location, we get 0, 0. And if we do loc.move left, it automatically updates, which is exactly what we want. And so it's actually, what's actually happening behind the scenes is a little bit tricky. Python has some special lookup on attributes. What property does is it creates, and this is gonna make advanced, don't worry if you don't know what this word means. We'll probably have an advanced video later where I explain this term, but property creates what's called a descriptor. And when you access attributes on things in Python, it goes through the descriptor protocol and allows you to basically make computed stuff. So even though I'm accessing it as a attribute here, behind the scenes it's calling this function and then like giving this value back. You can actually, so this looks like magic, and it actually isn't super magical. You can actually implement your own property. Let's see if I can get this right on the first try. Class property, def init self func. And don't worry about this. This is just me showing off. Is it instance and then owner equals none? I can never remember. This might be the other order, but we'll see. I believe it's just return self.func inst. Something like that. Let's try that. Give it a special different name than property, just so it's easier to tell the difference. So instead of using the property decorator, which I guess we can just leave commented out here, we're going to be using my implementation of property. This of course is not completely correct because property has setters and deleters and some other ways to do stuff, but we'll pretend it's good enough. Let's try this. Please be right. Please be right. Yes. Cool. Yeah, so that works. But yeah, this is essentially how you might implement a descriptor, and Python is magically calling this double under get thing, and then double under get is calling the function here. And if you're familiar with decorators from before, last time when we talked about decorators, we only talked about function decorators, but this @ sign here actually calls double under init, so it's a callable but in a different way. So that's getters. Properties also have setters, which let's just remove this since we don't actually need that. And properties also have deleters. I've literally never written a deleter property before, so I don't quite know where you would have a use case for that, but it's certainly possible. But anyway, this is how you implement a setter. A setter takes the previous property, so loc here is referring to this function that happened to get decorated with property, and you do loc.setter, and it has this signature. So you'll have one argument that you take here, and you'll be able to do some logic here. So let's say that we're setting loc. I don't know, the places where you would use a setter seem kind of rare to me. I have very few of them in my code bases, but some things that you might do in a setter is like, I don't know, input validation, or maybe, you know, this case is actually kind of a reasonable example. Like maybe you want to set both x and y at the same time. Of course, you could do that by just doing loc.x, loc.y equals, you know, 5, 4, 3 or whatever. So that would work. But let's extend our example and use loc.loc here. We'll actually do what we would have suggested on the API here. But this implements a setter, so let's see how that works now. So if we make another location, and it starts at 0, 0, now we can assign to loc.loc. Let's see, let's set it to, you know, 1050. And now if we look at loc, we updated both x and y at the same time, even though we only did one assignment. And this is, again, some more magic. Well, it's not super magical. It calls double under set on the property descriptor, but descriptors, don't worry about them. But yeah, this assignment operator here calls into this function here and passes the right-hand side here as this variable. And so then we can, you know, do some special logic there. And there is a deleter here. I don't know. You probably wouldn't implement a deleter on a class like this, but let's say that for whatever reason, deleting location sets it back to 0, 0. So maybe we did something like this. So that'll get invoked. So let's do this again. Loc equals location. You'll notice that I'm rerunning this file every time I modify this, because there isn't any live modification here. Let's move right this time. So you can see we're at 1, 0. And if we call del, this is what invokes the deleter, loc.loc. Then you'll see that we've reset our location back to 0, 0. We should actually show, let's move right and up. Del loc.loc. Should have shown that it moved right and up first. Let me, okay, cool. So we're not at 0, 0, we're at -1, or 0, 1, -1. And then if we call the deleter, which again, this is a silly example for a deleter, I probably wouldn't use a deleter here. I would probably be a little bit more explicit, maybe something like move to origin and like do that. And like, I'd probably have a function that does this and probably not have a deleter. But this is a silly example for a silly video that I didn't prep for, so I couldn't think of an actual deleter example, so this'll have to do. But yeah, that's the property decorator and how you can implement, you know, a getter, a setter, and a deleter. Is there anything else I want to talk about in this video? Oh, actually, there's a cool new thing related to the property decorator that's new in Python 3.8. Actually, I probably should have done this earlier in the video. Just to show that it's getting computed every time. Let's add a print statement here. So if we run this again, you'll see every time I call this loc.loc, it's running this function. But we're going to extend this example and use a new thing in Python 3.8 called the cached property. And we'll actually have to import this one because it's not a built-in function. It's implemented in the Thunk Tools module, and what's sort of implied by its name is that, well, in a cache property, it doesn't have a setter and a deleter. It is only a retriever. So you wouldn't use it for this. You would use it in some other case, but I'll show you this example just because we already have the code written. The reason you wouldn't use it in this place is because it only gets computed once, and then after that, it always has the same value. So if we run this again, location, if we call loc.loc, you'll see the first time we call it, it's going to print this computing value. But if we call it again, it just immediately returns this value back. It doesn't do this computation again. And this is, again, like, you know, not completely magical. You could implement your own cache property. And actually, I have implemented my own cache property before because I needed this behavior in older Pythons. So this is Babby, which is my text editor, which is what we're using to demo this, actually. But you'll see here that I actually, well, and this is typed, so it's a little bit harder to read, but this is how you might implement your own cache property. You'll see, like, this is similar to what I wrote before for the other property. And the magic of it is it's setting an attribute on the instance whenever you call it, and this prevents the descriptor from firing. It's, again, pretty magical. We'll probably cover this more in detail when I talk about descriptors, but that's not this video. But yeah, and there is a way to get it to recompute this value again. You can call del on it. Now if we ask for it again, you'll see that it's recomputing. But again, it's the same. Like it only computes it the first time and then never computes it again. But yeah, I think that covers property and I guess cache property as a little bit of a bonus. Hopefully you guys enjoyed this video. If you have more ideas for other stuff you would want me to explain, either show up in my Twitch chat and, you know, give suggestions or leave a comment below. But yeah, thank you all for watching, and hopefully I'll see you guys around in the next one. Have a good one.